All right, we're back. This unit is all about inheritance. And in a couple of videos ago, we learned about polymorphism, which simply put allows you to do this. We have a person variable referencing a student object. And this can work because student extends person. As we kind of learned, student, college student, teacher, anything that is equal to or beneath person in the class hierarchy can go into a person variable. Now, this creates a situation where we have a compile time data type, the data type of the variable, as I like to think about it, and there is a runtime data type, the data type of the object. Now, that's cool. What it allows you to do is kind of overload your methods, we actually kind of saw a very recent example where you have like a checkout method that can take in any person object. Anything that is equal to or beneath person in the class hierarchy can be passed into this. You can pass in a person, obviously. You can pass in a student. You can pass in a college student. You can pass in a teacher. And then the method can change its functionality kind of based on that. And this is better than overloading, because if you made a checkout method for a student, you made a checkout method that took in a college student, you overload this thing 4 times, it's likely it's going to have duplicate code, right? There's going to be stuff in there that is basically the same up until the point where it matters what object you have. So by doing it this route with inheritance and being able to take in any data type, you're able to reduce duplicate code. So that is one advantage. We also went on to see that you can create like an array of person objects. And with that, this can store not only person objects, but it can store students. It can store college students. It can store teachers. And that is super awesome because this is very practical. I gave you the example of where your video game that you play, likely all of the things, in order for them to interact in the same world, they have to have a common ancestor, something that I called like a game object. In that you would put in data that all of the game objects share, such as a position in the world. If it's a 2D world, it's an XY location. If it's a 3D world, you're talking about an XYZ location. So the reason why you want them to have a common ancestor is so you can put them in the same 2D array, the same 3D array, so that they can actually interact with each other. Where is the position of this thing in relation to my other thing? So that is super practical. That was the kind of polymorphism. And then we went on to learn that object is at the top of every class hierarchy, because if a class does not explicitly extend something, person is an example of this, right? Person isn't extending anything, except it is. If you do not explicitly extend a class, you will implicitly extend object. And if you think about that for a moment, everything we've ever written ever is ultimately has object at the top of the class hierarchy, right? We've written like cards. All the drivers that we have written are technically extending object. So what that means is the class hierarchy, right? I'm only showing kind of a portion of it. Above person is object. Here, there are some methods that are being defined in object, and they're going to get inherited on down. That is true for everything you have ever written ever, because object's at the top of everything. Okay, ultimately this means that object is the top of every class hierarchy. The methods defined in object will be inherited by all the subclasses in the class hierarchy. Okay, we went on to look at some of the methods, right? Sum equals isn't super useful on its own, right? It's meant to be kind of a placeholder that we are supposed to override and provide our own implementation. ToString is a similar situation. ToString on its own is not very useful. That is the data that you get whenever you print off something without a ToString, right? The example of this is if I comment out the ToString here, and then I try to print off a person. We'll come back to this library thing. I'm going to make a really quick person. And if I try to print off P1, keep in mind that we are calling ToString. We are calling the P1.ToString implicitly. What we're going to end up getting here is kind of the hash code. This is the hexadecimal location in RAM, right? We see F and D F will be like, the last letter that you'll ever see, but A, B, C, E, those are all possibilities along with this D. Anyway, this is coming from objects toString because as it stands right now, my implementation, person doesn't have a toString, except it does. Person is extending object implicitly, and so it's going to inherit the one from person, which does this. Again, not super useful to us, but here's what it allows. Right here, where we are implicitly calling toString, Java can kind of do this because it knows everything has a toString. Even if you specifically did not write a toString, you still got the one that you inherited from person. So we can take this liberty. We can have this shortcut because we know everything has a toString because objects at the top of every class hierarchy, so it'll inherit down. Other methods such as getClass, which is where we kind of stopped our last video. getClass is useful because it is how we can find out the runtime data type. Okay, what do I mean? With polymorphism, I can pass in any person object here. Student, teacher, college student. Those are all possibilities that can come in through this because of polymorphism. What that means is I don't know the runtime data type. I don't actually know what object I'm getting until we actually execute the method. But this is how we can figure out what is the runtime data type. What object did I actually get? Right? We take the person variable. We pull out its class, which as we saw in our last video is a literal class object. And then class, that object, when I say class, I mean with a capital C. There's a class called class in Java. Yeah, I know. We can ask what is the name of it. And specifically, because of our class hierarchy, we're going to get person, student, teacher, or college student into our str, into our string. So based on that, I can kind of change the implementation. But this is better than overloading checkout with like 4 different versions, one for student, one for teacher, one for college student, because the duplicate code, maybe before and after, ends up in one spot. And then I can kind of change something in between based on who it is actually. So I know the compile time. Person is going to be a person object, right? I don't know the runtime. This is basically compile time right here, right? Like I'm looking at the source code. I know at compile time what the data type is. I don't know the runtime data type until we actually execute the program. And that is why those names show up. I know the data type of the variable. I don't know the data type of the object until we actually execute. So that was the purpose of this. And what is important is that getClass, that's coming from object. Right? That is a method that is inherited from object. So getClass is how we can find out the runtime data type of the object. Now that we're coding with inheritance and using polymorphism to our advantage, getClass is useful as we can dynamically determine the type of the object. If you don't do the getName portion, this would literally, in this case, print class student. Right? The word class is in there, and that is why I was using getName. So that's an example of that, and we're going to pick up there. Another useful method is clone. Clone construction returns a copy of this object. Recall that the assignment operator can be used to change the reference of an object variable. Setting 2 object variables equal to each other with the assignment operator gives them the same state because they are in fact the same object. If I create a student and say it's a new student, and then I say S2 is going to be equal to S1, they're going to have the same state because it's literally the same object. The scenario I have is 2 variables going to 1 object, right? The variable S1 is going to point to this object. The variable S2 is also going to point to this object. Clone is useful when you want 2 objects to have identical states without referencing the same object. However, note that clone returns an object. Look at our data type here. It returns a literal object. What do I mean? Okay, let's pause for a moment. As we've learned, object is at the top of every class hierarchy. Something else we've learned is that we can come in and make something like a person array called people. And with that, I can, ooh, almost try to treat it like an array list. We could do an array list. We could do an array list. Let's make an array list of person objects, and we're going to call that people. New array list of person. Okay, I need to import this, so I'm going to hover over it, hit Alt-Enter. Ta-da! And then we're going to take people, and we're going to add a new person. I'm just going to call the noargs constructor to prove the point. We're going to add a new student. Now, this is somewhat recently added to our toolbox. We can do this because student extends person. I'm going to add a new teacher. And this works because teacher extends person. The last thing that is super interesting here, and I want you to think about how this is different from the previous two examples, is that we can add a new college student. Say what? IntelliJ is not mad. Are you mad? I'm going to loop through my person array list. I'll say for each person, which we will call person in people. I'm going to print off the current person. Okay. IntelliJ is not mad. Let's try to actually run it to see if there's any runtime issues. Maybe, yeah, there's no runtime issues here, right? I need to bring back in the toString. Apologize. And it looks like student. Okay. Yep, student was relying on the one that person was doing, and person didn't have one temporarily. So I'm going to run this again. That's much better. This is coming from the very first element, which is just a basic person. This is our student. This is our teacher. And this is our college student. Okay, this is polymorphism. What is so cool about this is that I'm able to actually put any data type that is equal to or beneath person in the class hierarchy. Obviously, a person could go into this person array list. Student can go into it because it is beneath person. Student extends person. Teacher can go into it because teacher extends person. But listen to my language. We're able to do this because the object's data type is equal to or beneath person in the class hierarchy. Okay, college student is ultimately beneath because college student extends student, which extends person. So college student is in this class hierarchy. Okay, now with this, we are limited. The data type of the variable is person, which means I am limited to calling person methods. If I put a dot here, I can only call person things. What am I getting at? This clone method specifies object. This isn't a generic thing. This is literally an object. Now that we know about the object superclass, and we also know it is at the top of every class hierarchy, you can do this. This works because all of these things are equal to or beneath object in the class hierarchy, right? Person extends object. It does so implicitly. You can do it explicitly. It's going to happen no matter what. If you're not extending something, you're going to extend object. So, because object's at the top of every class hierarchy, that means a person can go into it, a student can go into it, a college student can go into these variables, right? Each of these slots is effectively a variable. You can create an object variable and say it's a new person. So what I am saying is this is literally a data type. Because it's a class, it's literally a data type. You can do this. This is not very useful. There's no instance variables, right? There's some methods, but if there's no instance variables, then this doesn't really do anything. But it is a data type. It does exist. I can create an array list or an array, any data structure that takes in objects as a data type, and I can add anything to it. But I am limited. Take a look down here at my for each loop. Because the data type, the compile time data type of person is now object, I am limited to, I can only call object methods. If I hit the dot here, here's the methods I can call. That's it. Right? It's like those 8 or 9 methods that are in object. That's it. That's all we have access to. Now, one of those is toString. So if I run this, this is where the polymorphism kicks in. Because the compile time data type tells me what I can call. In this case, I can only call object methods. However, the runtime data type says what will be called. This first object is a person. So whenever I call toString, I can call toString because object defines a toString. However, the toString that I am calling is person's toString. You can see that here. When I'm on this element, I can call toString because the compile time data type is object. The runtime data type is student. So whenever I actually do execute it, we're calling students toString, and so on. That is also polymorphism. This object here, it's a literal object. Note that clone returns an object. Unless you were saving the object returned by clone into an object variable, you're going to have problems. What do I mean? Here's student, S1. It's a new student. Okay, we just saw the whole point of this is I want to be able to duplicate S1 without just pointing to the exact same object. I want to create an object that has the same state as S1, but is not literally this object. I'm telling you that clone can help you do that, but it's returning an object. Why is that a problem? If S1 is a new student and I take S1 and I try to clone it, I'm not getting back a student. The runtime data type here is not student, it is object. I'm trying to save object into student. Is object equal to or beneath student in the class hierarchy? No. Because object is higher up than student, I can't save that higher up thing into student, right? If this was a person, right? If I was trying to save person into student, I think it's a little bit more clear. You can't do that. What we learned is that we can do the opposite. We can save a student into a person. So this is the problem, and this is what this video is actually supposed to be talking about. It's a big lead-in. If we were to do this, okay, notice that the compile time data type of S2 is now object. I can save object into object because object is equal to or beneath object in the class hierarchy. This works, but now look at the compile time data type of S2. I am limited to object methods. Why don't we demonstrate this in code? I'm going to say S1 is a new student. I'm going to create S2. And if I say that's equal to S1, that's a problem because they have the exact same pointers. What I want to be able to do, or they're pointing to the same object, I want to be able to clone. Now this method comes from object, right? If I do S1 dot, is it really not even suggesting clone as an option? Interesting. What does it say here? Has protected access. Interesting. I don't even know what that means. Well, I do know what it means, but it's a problem. Oh, maybe we can't clone. Maybe this is just a hypothetical issue. I'm going to keep going. Because what this is leading into is casting. We've talked about casting before. here I have a double, and I want to save this value in, right? If I just said integer y is equal to x, that's a problem. I'd be trying to save a double into an integer. However, with the cast, we can force this thing to be treated as an integer. Now, that's going to get rid of the fractional part, so there is some data loss here. However, it'll be 7. You notice this doesn't matter this much in this example because it's a 7.0 anyway. Casting can be used with objects in order to convert the data type of the variable. I wonder if this works, if I can just apply the cast. This protected access thing has got me stumped. I feel like I've done this example before. It's not even showing up as an option. That is crazy train. What if this was a person? Just doing a little experimenting on a video that will eventually hit YouTube and exist forever. Not embarrassing myself at all. Nope. Interesting. So, I'll demonstrate it here. With person, right now, the compile time data type is object. So I am limited here. I can only call object methods. That kind of sucks, especially when, right, I have other things there. So what if I want to be able to switch based on the runtime data type? Okay, so let's just say when I'm on this object, I know it's a person, so please just let me call person methods. I can't because the compile time data type is messed up. The casting is a way to basically change the compile time data type. Casting removes the compile time issues with saving a superclass into a subclass and instead makes it a runtime issue. Casting works as long as the object's data type is an instance of the cast data type. So here is a word. Notice it's in a different font. This is an actual operator in Java, right? The word instance of is an actual reserved word, right? Notice that it's orange here. It's missing some data, which is why it's mad at me, but it is a reserved word. That thing I said earlier about being equal to or beneath in the class hierarchy, that's effectively what instance of checks for. Instance of is an operator that evaluates to true as long as the specified object is equivalent or beneath the specified data type in the class hierarchy. False otherwise. I'm going to say specified runtime data type. Instance of is an operator that evaluates true as long as the specified runtime data type is equivalent or beneath the specified data type. I'm going to leave it at that in the class hierarchy. False otherwise. Okay, so you're going to take some object variable that's going to have your runtime data type, and we want to know, is it an instance of some data type over here? I want to know, is stu, some type of variable, an instance of student? Okay, let's take a look. Here I have person. It's a new person. I want to know, is p an instance of person? This operator is returning a true or false value, which we are saving into a Boolean, and I print that off. Yeah, p instance of person. This is going to return true as long as this thing has a runtime data type that is equal to or beneath this data type in the class hierarchy. Is person equal to or beneath person in the class hierarchy? Yes, obviously. Okay, here's where it gets interesting. Here I have student. And I want to know, is student equal to or beneath person in the class hierarchy? Yes. Note that this compares the data type of the object, the runtime data type, not the data type of the variable. Ah, that is why my slides did not say that here. Let's change it back. as long as the specified variable, I think is what it said before, is equivalent or beneath the specified data type. Because here I am clarifying. Note that instance of compares the data type of the object, the runtime data type, to the specified data type. Here's an example that clarifies on that. Here I have person S, and that is a new student. Well, the compile time data type of S is person. The runtime data type is student. I'm asking, is student equal to or beneath person in the class hierarchy? Yes. Okay. Is student equal to or beneath student in the class hierarchy? Yes. Notice that if this was looking at the compile time data type, I would be asking, is person equal to or beneath student in the class hierarchy? And I would be getting a false value. Okay, so instance of is looking at the data type of the object, this bad boy right here, the runtime data type, not the data type of the variable. Okay, here I have an object, S, and it is a new student. I can do this, first of all, I can do this because student is equal to or beneath object in the class hierarchy. This works because instance of is true. That's kind of interesting. Here I'm asking, is student an instance of person? Is student equal to or beneath person in the class hierarchy? Again, we're looking at the runtime data type. If this was looking at the compile time data type, I would be asking, is object equal to or beneath person in the class hierarchy? And we would get a false value. Okay, so we look at the runtime data type here. An object variable can reference an object as long as the object is an instance of the variable's data type. That's kind of what I was just hinting at. This works because student is an instance of object. This works because student is an instance of person. Student is equal to or beneath person in the class hierarchy. That's what allows me to do this. So that is effectively what an instance of is asking. Is the thing equal to or beneath the other thing in your class hierarchy? So, casting isn't magical. We obviously can't cast a string into a student. Right? If I try to take I have object O, which is the string student. And what I want to do is take O and cast it. Well, this is going to give you a class cast exception. All exceptions are runtime errors, meaning you won't see this until runtime. A cast will work as long as the object is an instance of the cast. Here I have object O, and that is going to be a new student. I can do this because student is equal to or beneath object in the class hierarchy. So this works right off the bat. I'm going to ask, and this is the reason instance of exists, is O an instance of student? Is the runtime data type an instance of student? Yes. Okay. What that means is this cast will work. What the previous slide just said, the cast will work as long as the object is an instance of the cast. So what we're asking here is the runtime data type of O, student, an instance of student? Is student equal to or beneath student in the class hierarchy? Yes. Okay, then the cast will go through. All right, what about person? I am saving person into this object. Person is an instance of object, so that works. I'm going to say, is O an instance of student? Is person an instance of student? The answer here is no. This is false, and that's a good thing because it would break the cast down here. Let me show you. So I'm going to create a person, let's say person, it's a new student. And we are going to, first of all, why don't we ask, is person an instance of person? This is going to give me a true or false value. Yeah, of course it's always true. We'll comment this bad boy out for a moment. What I'm asking is student equal to or beneath person in the class hierarchy? True. Okay. Is student equal to or beneath student in the class hierarchy? True. Note that if this was looking at the compile time data type, we would get a false value. What do I mean? What if this is actually a person object? You see, we get a false value. What I'm asking is person equal to or beneath student in the class hierarchy? And that answer is false. Okay, so that is instance of. Why is it important? Because a cast will work as long as the thing is an instance of the other thing. What do I mean? So, let's have a student. I'm going to say the reason that this is even a cool thing is because the compile time data type limits what I can call. Right? The compile time data type of this variable is person, so I can only call person things, even though this is a student. So casting is a way to kind of convert that, right? I can create a student variable. And what I want to do, if I tried to do this, we got issues. And Java's not even let me do this because the compile time data type here is person. I'm trying to save a person into a student variable. But come on, bro. Let me cast it. Okay. Notice there is no syntax issues. I run it. There's no compile time issues. Why would you want to do this? Because student can call student things. So I have effectively changed the compile time data type of my variable. I've changed it from person to student, and now I can work with student. Okay, I know this doesn't look very practical at the moment, but I'm trying to tie it together, I promise. This cast works because student is equal to or beneath student in the class hierarchy, right? This thing is an instance of student. Person is an instance of student. We're looking at the runtime data type here, right? The compile time data type, it's person. But the runtime data type is student, which is why this works. Okay, so let's flip this a little bit and show you an example where it doesn't work. Person is a person, and I'm trying to save it into a student variable. Notice no syntax issue. This is just a warning. This is just a warning. And there's our class cast exception. This is a runtime error. All exceptions are. Okay, why? Because when I went to go do the cast, the runtime data type is person. The runtime data type of this variable is person. So we're asking, is person equal to or beneath student in the class hierarchy? That answer is no. That is where instance of comes in, because we can it provides a way to actually check it before we do the cast. If I just let this cast go, then it may cause a class cast exception. But if I perform a check in advance, right? If person is an instance of student, this is giving me a true or false value. And if it is true, I'm able to do this conversion. That error, by the way, is you can't, with no braces here, the only statement is we're creating a variable, and then we're not using it. So it doesn't do anything. And so this is effectively a syntax error of all things. It seems like it should just be a non-issue, but I'm going to put some braces here so we can do that. So I'm going to perform this cast, but only if I test the cast in advance. I'm going to run the exact same code, right? This just gave us a class cast exception. But if I run it now, nothing happens. right? We don't even enter here. I can put in an SOP where we actually print off our student. And you'll see that we don't even enter the body because this is false. If this was a student, changing the runtime data type, you see we do enter the body, right? I save a student into person. This works because student is an instance of person. Student is equal to or beneath person in the class hierarchy. That is what one of our slides was saying about why this even works, why you can save a different data type into a different data type. Here I'm asking, is the runtime data type, student, an instance of student? In this case, yes. That is an important check because it means that this cast will work. I've already checked this, really. Is the runtime data type, student, equal to or beneath student in the class hierarchy? Yes. Then the cast will work without giving us an exception, and we effectively change the compile time data type. Okay, why do you care about changing the compile time data type? This seems really stupid. Why didn't I just make the object in advance? Right? Why didn't I just make this thing a student to begin with? I'm going to comment this out, and I'm going to bring this one back in. The compile time data type, the reason why we care about changing the compile time data type, I technically made a new variable, but it is kind of simulating changing the compile time data type, is I am limited in what I can call. I made this thing an object array. The reason being is that I could save different data types in it, right? The same concept applies if it's just a person. Let's change it to person because I think that is going to make more sense to people, to students. By doing this, however, whenever I loop through, the compile time data type of each of these elements is person, which means I am limited to only being able to call person things. But I know there's other things in here. Maybe I want to get the ID, right? If I want to get the ID, I can't. I want to get the GPA, I can't, unless I change the compile time data type. What if I made a student and I try to save person in? Well, I can't do that because I'm trying to save a person into a student. But what if I cast it? Aha! Notice no compile time issues. When I go to run this, I get class cast exception. Why? Well, that didn't work here. And it doesn't work here. And it may work there. The cast only works if it is a student. If person, the current variable, is an instance of student. If this is true, I can do the cast. I effectively change the compile time data type. Why is that important? Because now I can get the GPA. Right? I couldn't do that a moment ago because the compile time data type was person. But by effectively changing the compile time data type of student, I can now call other things. Think about this in terms of the game world example I keep giving. I want to loop through all of my game world stuff and tell them to perform their actions. But when I'm on my hero, I want my hero to do something specific. When I'm on the enemy, I want it to do something else. They all have a central data structure so they can be in the same world and interact. But I am limited by the idea that they can only do game world stuff, right? When I'm on the specific hero or the specific enemy and I want them to do something that pertains specifically to them, I need to convert the data type so I can even do that. That's what we're doing here. If the person is a student, we can print off their GPA. For instance, I'm going to get rid of this SOP momentarily. So take a look at what our loop is doing. I'm going to loop through the entire array list. If the current thing is an instance of student, then we're going to print off the GPA. Okay? In the case of person, they don't have a GPA, so nothing's going to happen. In the case of teacher, they don't have a GPA, so nothing's going to happen. But you notice for student and college student, something does happen. Right? So when I'm on this first object, we're going to ask, is the runtime data type of person equal to or beneath student in the class hierarchy? No, that's false. We skip over it. We go on to the next one. We're at student. We're going to ask, is the runtime data type of person, this student, equal to or beneath student in the class hierarchy? Yes. I enter the body of this if statement where we effectively change the compile time data type so that I can then call the GPA method. We'd go on to the next person and ask, is teacher equal to or beneath student in the class hierarchy? No. We don't enter the body. And it's a good thing that we don't enter the body on person and teacher because the cast would break. Right? That's the whole point of putting this as an if statement as opposed to just blindly doing it. It's not a syntax error, but I will get a class cast exception. Okay? When we're on our last object here, we're asking, is college student equal to or beneath student in the class hierarchy? It is. College student extends student. I perform the cast where I turn it into a student, and I can call specifically student methods. Right? That includes things like GPA ID. Notice it does not contain the college student stuff, but that at least gets me a GPA, something that a college student and a student have. This is kind of the point. This is why you would cast. When I'm looping through this array, I don't necessarily know what the runtime data type is. I know what the compile time data type is. Of note, something similar would happen here in the checkout method. I have all types of person objects coming in. This provides a way to ask, is it exactly a person? Is it exactly a student? However, instance of would provide a way to ask, is it equal to this thing or beneath? Which is an example we see like with student and college student. So I don't know the runtime data type. Instance of and the get class get name provide ways of checking to see what is this thing exactly so that I can get exactly what I want. That is going to be a good spot for us to pause, and I will see you in the next one.